Gas can easily be kept in a balloon, but in a balloon there is almost no pressure and therefore not much gas. And therefore transporting and selling great quantities of gas is not possible that way. However, when you see tanker trucks on the road, there is a very special feature. They contain gas in the liquid state. 1 liter of liquid nitrogen may later be made to transfer into 680 liters of gas. Such liquefied gases are very cold. Liquid nitrogen, for example, is very cold. It's about minus 196 degrees. Now I'm pouring out liquid nitrogen. And you can see on the table the cold gas is not lifted up. It's floating over the surface of this table. The cold gases, as we said, were traveling downwards because they are heavier than air. And we thought it might be interesting to see something which is unique. Everybody knows what a waterfall is. This is a nitrogen fall. Nitrogen is not poisonous, but more nitrogen in the air than 78% will displace the vital oxygen, creating a dangerous oxygen deficiency. And now what I'm going to show to you is what happens if nitrogen is traveling down into a pit or a cellar or something which is low, a low point somewhere on the floor. I'm lighting this candle here, and the candle burns in normal air. It's using the 21% we have in this air. And in my small aquarium here, there is also just plain air. And now I'm taking nitrogen, but in the liquid form. And you can see it floats over the edge of the beaker. And now I'm taking this beaker and placing it inside my aquarium. And you saw immediately what happened. The nitrogen was going down and extinguished the candle. Extinguished life, so to say. Now you saw what happened when the liquid nitrogen entered the aquarium, went to the bottom, and there expanded from liquid into gas. So you can see I really mean expand, because it's a very large quantity of gas you get from a small quantity of liquid, which is very good, because when you are distributing these cold gases, you can have them in a tanker truck. Some words for caution are needed, because it expands to very much gas. As you can see, when I now pour this nitrogen into the jar, and now I will be closing the jar. And now you can see what's happening. And I know what's happening. Well, you will agree, lots of gas. And also, when designing gas systems, you should remember that never close in liquid in between two valves. Never trapped liquid in between two valves unless you have a safety valve there. These liquid gases in the liquid state, are very cold. We are speaking of very low temperatures in the order of 183 degrees Celsius for oxygen and minus 196 for nitrogen. These temperatures are low and can preserve, for example, food, and they also the liquids contain such large quantities of cold that you can cool down things very rapidly, and also you can cool them down without losing the fine texture, as for example, you look at this flower here, and I'm pouring liquid nitrogen over the flower. Just for this short while in the liquid nitrogen. And it's still looking like the same flower we had before, but it's not the same flower. It's very brittle. These cold liquids are excellent for preserving food, like vegetables, meat, fish, shrimps, and so on. But let's consider what could be happening to living tissue like the human skin, because permanent injury might be happening very rapidly. We like to remind people who handle cold liquids that they always should keep their trousers legs outside their boots, because if the trousers legs are inside the shaft of the boots, liquid spillage might enter and you might not be able to get your boot off rapidly enough in time. And now we imagine these are your toes. Now this is something which is more or less extreme, but we may use this just to teach people to be very careful. Many materials will get hard. It's not only that we saw that the sausages in the flour, but also metal will be solid, as this lead bell here. You can hear it does not sound, it does not ring. It's rubber and lead. And now I'm going to put this bell down into liquid nitrogen and wait and see what happens. You see, at low temperatures, the molecules, even in metals, contract. The lead bell had shrunk. This is a physical effect we can make use of in an interesting technique in joining parts together. To show you an example, I have a shaft and I have a disc, and this hole is milled so that it is slightly smaller than my shaft, and it can't get onto the shaft can't enter. And now we will see what happens when I cool the shaft down into this vessel with liquid nitrogen. So let's now see what happens. And now I have got a joint which is very good, and I did not use any methods like welding or heating, when the temperature has evened out, these parts will be firmly joined together. Electrical resistance in conductors may entirely disappear at extremely low temperatures. Also, magnetic fields are influenced, and special ceramics may enter superconductivity at minus 185, the so-called Meissner effect. We have this little container here to give us a possibility of cool down the ceramics, and I have here a small magnet which I will put on top of this. As you can see here, nothing happens really now because the magnetic field of this magnet is penetrating the ceramics, and there is no effect of attraction or nothing else. And now you see what's happening. The magnet is floating freely above, and this is because that now the magnetic field cannot penetrate the ceramics, and the ceramics now has generated a field of its own which is opposite to the magnetic field of the magnet.